This is the ROS Developers Podcast, episode 66.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo Tellez here today from The Construct, and today I would like to dedicate this episode to all those ROS developers that are that are using Gazebo simulation as the primary tool, to test your robot code before pushing it into the real robots. So if you are doing this good practice, then this episode is dedicated to you. Today, I'm going to talk with the lead developer, the tech lead developer of Gazebo Simulator, and she's going to tell us about the next generation of Gazebo, which is a complete rewriting of the simulation based on a new set of libraries, the Ignition libraries. And all those subjects and then all those questions that we are going to ask her, they are going to be answered today. But before going into that, let me remind you about our ROS Online Academy. And at The Construct, you know that we have created an online academy for learning ROS, which is named the Robot Ignite Academy. It contains a ROS learning path for beginners. And on this learning path, we start by teaching you about Linux and Python for robotics. So if you don't even know about these basics, you can learn it there. And then we continue teaching you all the basic ROS concepts required to become a ROS developer. And then we conclude in the final chapter of this path, we conclude with a course where we teach you how to build your own physical robot and how to ROSify it. That means to add ROS control so you can finally become a complete and full ROS developer. And by the way, we have also added recently on this month, on December actually, we have added a new course about how to program web interfaces for ROS robots. And it's a course that teaches you how to build web pages that connect to ROS robots and allows you to present the information of the robot on a web page or control the robot from that web page. It's a very pioneer course in the world. It doesn't exist anything similar in the world. So I will put a link to those courses and to those ROS learning path on the show notes of this episode. And now it is my pleasure to introduce you to Louise Poubel. This is the second time that I interviewed her here in the podcast about her work on Gazebo Simulator. And for all of you who doesn't know her, Louise is a senior software developer at Open Robotics. But more than that, she is the tech lead developer of simulations simulator at Open Robotics. Specifically, she is at present leading the development of the newest version of Gazebo, which is based on the Ignition libraries. And this is called the Ignition Gazebo. And on top of that, I like it very much that she describes herself as a citizen of the world. And I love that. So welcome to the podcast, Louise.
Hi, Ricardo. It's nice to be back here. Thank you for the invite.
Yeah, my pleasure as always. And I like this description that you put on your LinkedIn about being a citizen of the world. What can you tell to the audience? Why do you describe like this?
It's mainly because I've lived in so many countries that people ask me, like, where are you from? And I have a hard time answering because I've just been everywhere. So I'm originally from Brazil. I went to college in Japan. Then I did my master's in Poland and in France. Now I'm living in the US. And people ask, like, where are you from? And I ask, well, what do you mean? Where I was born, where I'm right now,
Okay, yes, that's right. That's a complete citizen of the world. I mean, all the countries. I think you are missing Africa, maybe?
I know, yeah, maybe that's the next destination.
Next destination, exactly. Exactly. So very excited to be here with you and talking about this new generation of Gazebo that everybody is waiting for it, you know, because Gazebo is very nice. So we have used it a lot, but it has some, it lacks some stuff. So it's very cool that you are moving into a next, let's say Gazebo 2. Can we say, no, Gazebo 2 we cannot say.
There is a Gazebo 2, right? It was released years ago or something, yeah.
Okay. Yeah, so we cannot apply the same name convention as in ROS and ROS 2.
Yeah.
Okay.
Unfortunately not.
Okay. Well, the name is the less important thing, I think. So let's go to the meat of the subject. What is about those ignition libraries? What are those?
So the Ignition project as a whole is a complete rewrite of Gazebo. We do pull a lot of parts and a lot of things that we learned from Gazebo, but we changed a lot of the architecture. We incremented a lot of things. We're using more modern practices, more modern libraries to create a new simulator that addresses some of the shortcomings that Gazebo had and also addresses some new use cases that didn't exist back then when Gazebo was first written, because Gazebo Classic, like how we're calling the old Gazebo right now, is it's like a 16-year-old project or something like this. So it's an old code base, it's hard to maintain, it's very large, and it brings a lot of baggage. So we just wanted to develop something new that is like addresses a lot of user concerns and user use cases now.
Okay, so those libraries, they try to, so the main goal is to try to solve the drawbacks of the Gazebo Classic.
Yes, correct, and address new use cases. Yeah.
New use cases. Okay, which use cases are you talking about?
For example, now there is a lot of machine learning that relies on vision, for example, and the rendering in Gazebo Classic was not very realistic, so we are focusing a lot on realistic rendering for Ignition. There's also, now we have like all these computing power on the cloud, right? So people can run like simulations not only in their computer, but like in all these computers in the cloud. So we are putting a lot of focus on running simulation distributed across several machines on the cloud, so that you can really make use of that and really run very powerful simulations with hundreds of robots.
Okay, so
was very with the Gazebo Classic.
Yeah. So we all know when we try to put many different robots on the same gazebo, then it's going slower and slower and slower, and then at the end it becomes unpractical to use it. So now by using these Ignition libraries, it's kind of we can distribute the CPU load of a large simulation into different computers. Is that possible?
That's already possible partially. So we still have some features that we need to implement to really run a fully functional simulation distributed. You can already run it distributed across several processes or several machines, but right now the problem is that the robots have to stay in their own machines and they never see each other. If they kind of interact, we still are missing the part of the implementation that allows this interaction between different machines. But we're getting there, and that's one of the focuses for the next 6 months, to get that fully functional distributed simulation. Another thing that we have related to large environments is the concept of levels. So if you have a large environment that has no robots in that part of the environment, you can just kind of turn it off and on, and that's fully functional right now, and people are using it, and it really speeds up simulation because you don't have all those things in memory that are not being used because there's no robot nearby, right?
Yeah, that's very cool. Then, if I have understood correctly, then we have two kinds of improvements towards large simulation. The first one is that you are using kind of islands of processing for each robot. So if a robot is independent from other robots because they cannot see the other robots, then they are executed on different threads, and then by hence they can be executed in different machines, so you can distribute the load. This is first one. And second one is this label system that you mentioned about disconnecting some parts of the world that are of no interest for any robot, because no robot is there. So we don't have to waste our CPU resources there.
Correct. Yes, correct.
Okay. That's very cool, because I didn't have. It's very nice that you mentioned that, because I didn't have any questions related to that on my questions, and I didn't get this from the documentation of the Ignition Gazebo. That's very cool. So now I have understood that. And then, you mentioned about the Ignition libraries. This is one thing, but then is this something different than Ignition Gazebo? So Ignition libraries and Ignition Gazebo are two different things?
They are, in the sense that Ignition contains Ignition Gazebo. So Ignition is a collection of different libraries, or a distribution, if you want to call it. And it contains like Ignition Math, which is a math library. It contains Ignition Rendering, Ignition Physics, Ignition Transport, and Ignition Gazebo. Ignition Gazebo is just one of the other projects within Ignition, which is this larger project.
And then what is the aim of this larger project? Sorry, I didn't understand, because I thought that everything was related. So those Ignition libraries were kind of thought in order to create a better version of Gazebo, but by your comment right now, I understand that it's something more.
It is a set of libraries that work very well together so you can build a simulator with them, but nothing prevents you from using them for other things. So for example, if you want to use Ignition Rendering to do just rendering without any physics, so it's not a simulator, you can. Because it's isolated and it's its own thing. If you want to use Ignition Physics to do just simulation that doesn't have any rendering sensors, you can use that. So it's very modular, so people can use the different parts, because this is one of the feedbacks that we got from Gazebo Classic. People wanted to use just one part, but they had to compile everything and bring all the dependencies. So now everything is more modular. And inside this set of libraries, there's one library project called Ignition Gazebo, which is the one that kind of plugs everything together. So it pulls Ignition Physics for the physics, it pulls Ignition Rendering for the rendering, uses Ignition Transport for communicating, and so on.
Okay, now it makes perfect sense to me. So, for example, in our case, at the construct, we wanted to, for example, to launch many simulations of the same thing, and for reinforcement learning training in parallel. And then, so we had a lot of extra stuff that we have to launch with the Gazebo server that we didn't have to, but they were consuming a lot of resources. So now it's kind of more modular, because I can take only the physics that I'm interested for the reinforcement learning, and that's all, for example.
Yes. In Ignition, across the whole stack, it's very strong, this idea of don't pay for what you don't use. So that's reflected in the way that the libraries are organized, and the way that you build your worlds and you put them together, the way that the plugins are divided. It's all very modular. Even within Ignition Gazebo itself, you can launch Ignition Gazebo without physics, for example. It's very easy. You just turn it on and off in the world description. So it's more modular like this, because we know that some people are using it for crazy things like a simulator without physics. So, why not support that use case as well?
Okay, yeah, well, it depends always on the application that they are working on and so on. So I understand. Okay, and now I can see you. The audience cannot see you, but I can see you, and you are wearing a super cool T-shirt. Is Ignition Citadel, yes. Yeah. And then what is then Ignition Citadel? What is that?
So the way that we are organizing the releases of Ignition, right? Because it's not one library, it's several libraries that work very well together. So we are when we make a release of Ignition, we are saying that this set of versions of a library work very well together. And we call that a collection or a distribution. And each one that we release, we are releasing them in alphabetic order, kind of like how ROS and other projects do. And we name them according to this alphabetical order. So the first release was Ignition Acropolis, the second one Ignition Blueprint, and the third one Ignition Citadel, which is the latest one that I'm wearing the T-shirt. feature. So it's a specific combination of Ignition libraries that work very well together, each one with their own versions. But if it's inside the Citadel distribution, we assure you that they are going to work well together.
Yeah, well, it's the same as the ROS distributions. It's the same. In the same sense. Okay, and then this last one, so you have already launched three different versions of three different distributions of the Ignition libraries, set of libraries, and then the third one is the Citadel, as you mentioned. And what is special about it? Why is this so much, has something extra from the previous one's versions?
So this will be the first real long-term, like really long-term support, should I call it like this, because we are committing to supporting it for 5 years, which is, great. We didn't do this for Acropolis or Blueprint. And the reason why we chose 5 years is that we are planning to put it inside the next Ubuntu that is coming up, Ubuntu Focal 20.04. We're planning to put all the Ignition libraries there, so you can just install them without having to add a specific OSR Foundation packages. It's going to be just upstream. And that will also make it easier to use together with ROS and ROS2 and things like that.
And any new features from the previous versions that you can tell us?
There's been a lot of improvements in Citadel. One of the things I'm the most excited about is the frame syntax for SD format. So SDF is the description, like the format that we use to describe the world inside simulation, both in Gazebo and in Ignition. And from Citadel, we are supporting frame semantics, which is a much more powerful and flexible way for you to organize your model. So you can write the link pose of your link with respect to other links or with respect to other frames inside your model. You're not stuck to one way of describing your model like you were with previous versions, and that's much more flexible. If you change the size of a link, then your model is more behaves correctly. So that's exciting. There is also support for animated human actors that was not their own blueprint. Yeah.
That's very much requested by people. So we get a lot of people telling us, "Oh, how can we do these humans moving around?" And okay.
Yes, that's available from Citadel, and there's a bunch of other improvements. And since it will be supported for the next 5 years, we will be making minor releases with new features and bug fixes as well. So keep your eyes open because there will be more stuff coming up.
Okay, and then the question is, does this Ignition Gazebo work only for ROS2? Because it's what it looks to me by what you were mentioning.
No, actually, it works with both ROS1 and ROS2.
Okay, great.
Yes, it's actually for right now there are people using Ignition with ROS1 for competition, and we made the same support for ROS2 as well. As far as I know, there's nobody using it, but we never know with open source projects. Maybe there's a bunch of people using. Maybe there's no one.
Okay, so the competition that you mentioned is the Subterranean Challenge.
Correct. Yes.
Okay, and so in that one you are using ROS1 and Gazebo Ignition Citadel already?
No, it's actually using Blueprint, the previous version of Ignition. Yeah, maybe the next stages of the competition may use newer versions of Ignition. It's not clear yet.
Okay. And then let me see. So the next question is, okay, so I know now that I have this super cool new version of Gazebo. I want to use it. The one that I want to use it is the distribution Ignition Citadel. And then how can I interact with my ROS program with the simulation inside Ignition Gazebo? So is there a Gazebo ROS package like in the Gazebo Classic that I can use?
Yeah, so we have fully functional integration between Ignition and ROS, both ROS1 and ROS2. But the architecture is very different from that of Gazebo ROS packages, of what people were used to using with Gazebo. while Gazebo ROS packages was composed of a lot of plugins that were running inside the Gazebo process and publishing ROS messages straight from the Gazebo process.
Yeah.
The way that we're integrating with Ignition is more based on a bridge. So you launch your Ignition Gazebo process, it's running your simulation, then you launch a separate process that is your bridge, and that is just passing messages coming through Ignition transport to ROS, and the other way around too, from ROS to Ignition transport. So things are a little bit more separated, more modular, and a little bit easier to manage.
Okay, so then if I have understood correctly, then there is no Gazebo ROS control package that we have to load at the beginning. Instead of that, then we are launching this Gazebo Ignition bridge.
Yes, it's the name of the package is ROS_IGN, and that's a meta package that has several packages inside. The main one is ROS_IGN bridge. So it's the bridge between ROS and Ignition, and it has a version for both melodic and dashing, right? So for ROS 1 and ROS 2.
Okay, and then the plugins, where do they run? Do they run inside the Ignition then? No.
So for this ROS integration has no plugins. So what is running inside Ignition is all Ignition plugins. There is a bunch of plugins. We can talk about them if you think that's interesting. But the ROS integration itself is not based on plugins. That's running on a separate process that is just listening to Ignition transport messages on one side and listening to ROS messages on the other side. So it's not a plugin because it's not running on the Ignition server. For example, if the bridge crashes, it doesn't crash your simulation because it's just a separate process.
But then how do we get information from a sensor from inside the simulation? So I don't see the process.
Okay, so for example, your sensors, just like in Gazebo Classic had its own transport, Gazebo transport, and it was publishing the sensor messages through that transport, right? But ROS was not using that. ROS in Gazebo Classic, ROS users were taking messages that were being published directly through ROS from the simulation process. Exactly. Now in Ignition, we are still publishing these messages through Ignition transport.
Okay.
So there is a simulation process that is running separately, and it's publishing all this information through Ignition, the Ignition interfaces. And then this other bridge process is listening to those. So for example, you have a point cloud being published by a sensor inside simulation that's publishing a message that is not understood by ROS. It's only Ignition transport. So this bridge listens to that, converts that to ROS, and republishes that to ROS.
Okay.
And the other way around also works. If you send a command using ROS to your robot, the command goes to the bridge converts that message from a ROS message to an Ignition message and republishes it to simulation, and the simulation
can get the data. Yeah, like for example, a velocity command for the wheels or something, then that's a way that you can send from ROS into the simulated robot. Okay. Then I have two questions related to that. So then when we do a ROS node list, then what we are going to see, we are going to see a node that is the Ignition bridge?
Correct.
Okay, and that's the one that is the publisher. Sorry.
Oh yeah, one or multiple, right? You can have multiple bridges, like one for each message type. For example, if you want to distribute the work across multiple processes, or you can have one bridge that bridges all your topics between Ignition and ROS. So it really depends on the architecture you choose. Yeah, and you can, the same way that you have the ROS node list, you have the Ignition node list. And the IGN, it's IGN topic list and so on, that you can see all the information from the Ignition transport side of things.
Okay, now I see the picture. And then the question is, why did you decide to change the typical plugin structure that we had in Gazebo Classic into by this one that is about the ROS bridge, Ignition bridge?
I think there are many reasons. For me, the main one is that to avoid duplication. So for example, you mentioned ROS control, right? Like one thing that people commonly do in simulation is to control differential drive robots. And in Gazebo Classic, the situation that you have right now is a lot of duplication. There is a differential drive native to Gazebo that doesn't know anything about ROS that you can use just with Gazebo, and will use Gazebo messages. And there is a differential drive inside Gazebo ROS packages that is another plugin that copies a lot of the code, but instead of using the Gazebo messages, is using the ROS messages. And if you fix the bug on one of them, the other one you don't fix, right? They're different code bases, they're released differently. So, and it's very hard to port them from one to the other, the fixes from one to the other. So it's hard to maintain. So with the new paradigm, you only have the differential drive in simulation, like in using Ignition code, and then you can use that directly with Ignition, or you can use that through the bridge to ROS. Because in the end of the day, all that ROS needs from simulation is certain information that is, most of it is already available through messages anyways, right? So 90% of the use cases is just getting sensor data from simulation or sending commands to simulation. There are other more nuanced cases, and I should bring this up, that you're not prevented from writing plugins for Ignition that run ROS. You can.
Okay.
Ignition has a lot of plugin entry points, a lot of different plugin types. And you can write, for example, an Ignition Gazebo system, which is a plugin that runs ROS code natively inside it and publish your raw data directly. Nothing prevents you from doing this. It's just that the most convenient way right now that most people are using is through the bridge, because it's all there already, and you just need to translate these messages.
I see your point, exactly. So nothing prevents you from including node handle inside the plugin itself, but that would be a kind of way of bypassing this Ignition bridge and just publishing directly. But then you are kind of breaking this structure that is already been in place with Ignition.
Yes, which is an alternative. You could use this and not use the bridge at all, just ignore the bridge and use it in your own way. For example, if you don't want to, if you have very heavy point clouds that you don't want to publish it through one transport, then translate it and then republish it to another machine. This retranslation can be costly, right? If you're running in the same machine, maybe in a single machine, maybe it's unnecessary. But if you're running, for example, in the cloud, you can have the bridge on a separate machine, so you don't really care.
Yeah, I see. Then you are sending a lot of data that is actually doing nothing, because you are receiving that in the bridge, translating and republishing again in a different format. So, and all that is getting into the network and taking traffic and taking CPU time and all that. Yeah, okay. So that will depend on the application also. Correct,
yes.
And if it is inside the machine, is it using kind of shared memory for this translation for the messages, or no? Is it even inside the same machine? If the bridge is inside the same machine as the Ignition Gazebo, this translation between messages is done by passing the messages, the complete information?
Yes, it's used by passing the messages right now.
Okay.
Yeah.
Okay. And then I'm already convinced. Okay, so I want to try Ignition for sure in the next days. But then I have a problem, because I have many other simulations already running. So are the simulations that already exist compatible with the Ignition Citadel?
Yes, so the SD format, we are using the same format that you use for Gazebo, which is SDF. So SDF is supported the same way. Ignition is still missing some parameters, right? So you may find that some parameters, for example, the bounciness of a surface may not be implemented in Ignition yet. Okay. But the idea is to support it in the near future. So we're adding features as fast as we can. But so the SD format description of the world and your models should work as they are. The only difference is the plugins, and that's a very big difference and very important. And right now, since the architecture, the internal architecture of Ignition and of Gazebo Classic are very different, the API is very different. So it's not straightforward to convert a plugin from Gazebo Classic to Ignition. And that's something we are trying to create APIs that make it easier for the users to migrate. But right now, you have to understand a lot of the architecture of Ignition before you can even start rewriting your plugins, right? But a lot of the plugins that come built in with Gazebo, we already rewrote them for you. So you have the usual things like joint control and differential drive and all of the plugin publishers, like the sensor publishers. This is all there already for you, but all your custom plugins that do something specific in simulation, you will need to rewrite it from scratch. And right now, that's the biggest pain. But we're trying to make it easier.
Okay. So yeah, for the typical plugins that we already use in our simulation, like differential drive or IMU sensor, something like that, you have already created the plugins in Ignition Gazebo. So the only thing that we should do in our simulation that we already have for Gazebo Classic is to replace one plugin by the other. Mm-hmm. If we want to run in Gazebo, in Ignition Gazebo, yeah, the old one, I want to run my old simulation of Gazebo Classic into Ignition Gazebo. Then the SDF of the simulation is the same, so I don't have to touch it. And then the only thing that I have to go is inside the SDF and see where are the plugins, and then replace the one by the new way of launching the plugins. I don't know if there is a new way or is the same syntax, but just the name change.
It's the same syntax. It's a plugin tag inside your SD format. But the name of the libraries will be different, and the parameters that they take will be different. So if you try to load a Gazebo plugin into Ignition, it's not going to work.
Exactly.
You will need to change that. Yeah.
You have to change this library of the plugin and then the parameters, and that's it. For an existing plugin. Then for your own plugins that you have developed, that's where you have to go to the documentation, look at the API, the new API, and then rebuild it, basically.
Yeah, rewrite it.
Rewrite it. Okay, great. And then, so you mentioned that it's supporting, but we have more things here. So apart from the SDF, then we have the plugins and also the URDF of the robots. So is it URDF supported also in Ignition Gazebo?
Yes, URDF works. You can, for example, load pass a URDF string of a model and pass it to Ignition, and Ignition will understand it and launch it. The only complication with URDF right now is that the main way of storing your models and for Ignition to find your models is through the Ignition Fuel website. So if you go to app.ignitionrobotics.org, that is a website that has a huge database of a lot of SDF models for you to load into Ignition. It's like super convenient. You can drag straight from your browser straight into simulation, and the model is there. But the problem is that only supports SDF right now. So if you have a URDF model, you have to load it through other means. You can't just pass the URL of the robot in the website. You have to, right now it's not the most convenient. You probably have to pass the string itself because it's not going to find the file. And we are trying to improve that and make it a little bit easier for you to find those files on disk.
Okay, so we cannot do a spawn of the URDF model as we were doing in Gazebo?
Oh, you can. Yeah. If you spawn and you pass like the string or the full path to your URDF model, you're going to spawn it straight away. And and you can even do it from ROS. In the ROS_AGN repository, you have like packages that help you to just like do that from a ROS parameter, for example, from the robot description parameter. You can already do that. Exactly.
That's what I was thinking about. Okay, so then there is no problem on using our old URDF models.
The main problem will be finding it. So Gazebo Classic had the Gazebo model path environment variables, the Gazebo plugin path environment variables, and we're still lacking the equivalent of that in Ignition. So, but if you pass the full string through robot description, for example, then you're good to go. It's gonna work. If you have some mesh that you need to find, that will take
I see.
more work. Yeah.
Okay, I see. Yeah, I usually use the only way that I spawn robots in the simulation usually is by using the robot description, so on the spawn process. So in my case, that would be okay. And also wanted to ask you for your personal opinion about that I recommend to the people to define their simulation, the wall, all the stuff that is moving around the wall that is not the robot, to use the SDF format, but for the ROS robot, use the URDF format, because the integration between SDF and ROS is still not working. I mean, for example, you cannot see the model. If you have your model of your robot in SDF, you cannot see it on RBIS, for example. Yeah, you know, so would you say that this is a proper way of working?
Yeah, right now, if you want to use a robot with ROS, it has to be in URDF because that's what all the main ROS tools understand.
Yeah.
And one thing that you've been able to do since forever is to convert URDFs to SDF. That's why you can load a URDF into Ignition or into Gazebo Classic. What's happening is that the URDF is being converted into SDF before being loaded.
Yeah.
And the other way around used to be very hard, converting SDF to URDF. That's why it wasn't so convenient to just write your model in SDF and have it translated to URDF. But now with the new frame semantics stuff that we've developed into SD format, it makes it much easier to translate SD format models to URDF. So we don't have a tool for that yet, but it will be coming up soon. And that will make it easier for you to just write everything in SDF. And then once you're sending it to ArcGIS, for example, you just convert it to URDF on the fly, and it just works. So the frame semantics is very powerful, and it's gonna open a lot of possibilities.
That's great. This is great. So then you have built the basis in order to build that tool that will convert. But the bases are there, and then we'll be able to use SDF for our robots too. Because SDF is a lot more powerful than URDF and allows them many other things to be described, the structure of a robot that URDF doesn't allow. So that would be more convenient.
More parameters, yes.
Yeah, that's great. Okay. So listeners, understand it's still work in progress. So it's advancing very fast, but please just be patient. They are working hard for that. Okay, and then let me tell you about other questions here that I have. So I'm checking on my list, and many of them you have already answered. And yeah, so you mentioned about the capabilities of Ignition Gazebo for large simulations, and you have already clarified that. But I wanted to ask you also about the visually realistic rendering. So how does it improve from previous Gazebo Classic?
So one of the main improvements in Ignition is the ability to plug in different rendering engines or physics engines. So unlike Gazebo Classic that you were forced to use Ogre for the rendering, and for the physics you had some flexibility, but you had like a few hard-coded libraries that you could use. With Ignition, it's all plugin based, so you can write your own plugin to integrate any rendering engine that you want or any physics engine that you want.
Nice.
So one of the first libraries that we're supporting for rendering is Ogre 2, which is the latest version of Ogre, which is the library used on Gazebo Classic. Yeah, and Ogre 2 comes with support for very fancy, new, modern, all the good buzzwords for rendering, mainly the physically based rendering, PBR. So it's rendering that is based on the real physical material properties of materials like metalness, roughness, and it makes everything look much better. So we are supporting that by default. If you download Ignition Gazebo right now, most of the worlds are using Ogre 2, and you get that already, and it improves a lot the visual fidelity of your world. But of course, you need to create those assets, right? We have a lot of them in Ignition Fuel, a lot of models that are using these PBR features, but if you want to use your own worlds, you have to be able to create them with the PBR features, which is very common nowadays for people developing video games and things like that. So we think it will be something easy for the community to pick up and start making good models, like good-looking models straight away.
Oh, nice. So I have seen the presentation at the ROSCON about this subject also. So I will put a link on the show note about this presentation, so people can see what to expect more from the visual new rendering capabilities of Gazebo, Ignition Gazebo. And then one practical question: can we have installed on the same system Gazebo Classic and Ignition Gazebo, and then switch between them at will?
You can have both installed side by side. That's not a problem. Switching between them is the problem that I told you beforehand. You can reuse the SDF worlds, but you can't reuse the plugin. So you could have the same models and load them into Gazebo Classic and Ignition with no problem. You can have like if you have a package right now with just robot description, that can be loaded into Gazebo or Ignition.
Okay, but let's say that they have the different simulations, so completely different for Gazebo Classic and another one different for Gazebo Ignition Gazebo, and then so there is nothing that prevents me from having both of them on the same computer and launching at will. So sometimes I would like to work on this simulation of this robot in Gazebo Classic, and then my large simulation for reinforcement learning is working on Ignition Citadel, and then at the same computer. Is that possible?
Yes.
Oh,
Yes,
great.
you can use them side by side. I use them side by side all the time.
Okay, great. And for what is going to happen to Gazebo Classic? So what is its future if you are developing this?
So we are right now, the team's focusing on releasing the last version of Gazebo Classic, which will be Gazebo 11, and it's coming up in the end of this month, end of January 2020. It will include a few new features mainly contributed by the community. It will be an LTS, so we're going to support it until 2025. And the idea is that this will give people enough time to migrate from Gazebo Classic to Ignition. So we will be fully supporting it, like pushing new minor features that are backwards compatible. As usual. So we're working on Gazebo 11 right now.
Yes.
Oh, sorry. No, yeah, I was just going to mention that Gazebo 11 uses some Ignition libraries inside it already, and we are right now bumping all the versions to make sure that they match Citadel. So you have the same Ignition Transport version inside Gazebo 11 and Ignition Citadel and so on.
And then this one, Gazebo 11, is going to be the default Gazebo version for ROS Noetic, the next version of ROS. The last
Correct.
one, the last version of ROS Classic.
Correct,
Classic.
yes. The last version of Gazebo Classic and the last version of ROS Classic.
The Classic, okay. And then let me see, a couple of questions more. So you mentioned that you have been using the Ignition Gazebo for the Subterranean Challenge, and how was the experience? So how was the feedback from the competitors and so on?
So I'm not really in touch with the competitors directly for this competition, but I've seen a lot of the videos, and I'm seeing a lot of what the rest of the team is doing with Sub-T, and it's looking very cool. Like, the competition has support for ground vehicles and flying vehicles, so it's mainly skid steering and also diff drive robots, and also flying quadcopters with quadcopters or hexacopters, and that's all working fine inside Ignition with these huge worlds. So these underground tunnels that are very long, and that they are using PBR rendering, so that they look very nice, and they are loaded and unloaded using the levels that I was telling you before. And there are teams with like more than 10 robots in the same simulation, and the competition is running on the cloud. So I think it's on the way. It's being good for the competition.
Nice. Can we see those videos in some way, or are they public or private?
Yes, I've seen a bunch of public videos. If you look up for the DARPA Subterranean Competition virtual track, because there's also one with physical robots, right? So the virtual track that is using Ignition, you can see all those fancy videos with the robots in the dark and the lights.
Okay. So I will look for that and then put a couple of links there on the show notes with the videos also. And then what are the plans of for the future version of Ignition Gazebo? What do you plan to include that is not already there and many people is asking you, or any errors or drawbacks that you want to remove from current versions of Ignition Gazebo?
Yeah, so our focuses right now is on closing the feature gap between Gazebo Classic and Ignition, because there's a lot of things that people coming from Gazebo expect, but they are not there yet in Ignition, right?
Yeah.
Especially like the user interface is lacking a lot of features. There is a lot of like the physics parameters, rendering parameters, and so on. So we're focusing a lot for the next release of Ignition on the user interface. And these are things I say for the next version, but if we implemented them in a backwards compatible way, even Citadel users would get them, right?
Nice.
So things like better like placing things in the world, seeing their properties through the user interface. We're also going to try to improve the plugin migration from Gazebo Classic, so adding interfaces that are more similar to what you would expect if you're coming from Gazebo, to make that migration easier, better support for ROS packages and models that are hosted inside your local directories, things like that are what we're working on. And some things that don't exist in Gazebo Classic either, right? Like Ignition has a lot of things that you don't even get in Gazebo Classic. For example, now we have a thermal camera that you don't have in Gazebo Classic, and other things like this that we are adding.
Nice. And also I saw something on the documentation related, for example, to located winds. So you can apply kind of wind forces into different areas or something.
That's on the roadmap. Yes, that's coming up soon. That is necessary for the subterranean competition. So yeah, we're working on that. Okay,
so one final question is about the naming. So you are calling this, is it called Ignition Citadel, and the previous one was Blueprint? So where does it comes from, those names?
Yeah, so we, as a team, we got together and we thought, well, okay, how are we going to name this new thing that we're working on? And we chose the architecture theme to stay close to Gazebo, to keep the Gazebo spirit alive. So everything is related to architecture. So that's why Acropolis, Blueprint, Citadel, the next one coming up in September 2020 is going to be called Dome. Letter D, it will be Dome. Yeah.
Okay, the Dome. Okay. Okay, interesting. I think that you are very creative at Open Robotics in all those stuff, and the names, also in the icons and the images to represent all that is very funny and very nice. Okay, so thank you very much, Louise. It's been a pleasure to have you here a second time and to learn a lot about this amazing project that is Ignition Libraries and Ignition Gazebo. Thank you.
Oh, thank you, Ricardo. Yeah, it's nice to be here again. This was fun.
Yeah, thanks. And that is all for today. So if you like the podcast, please subscribe on iTunes or Stitcher, and also support our work by giving us 5 stars and a review in iTunes, for example, and telling us what do you think about the podcast and what you would like to have. Please support us with that if you like the podcast. And you can also send me an email if you want to, tellus@theconstructsim.com. I will put the email on the show notes, because we need your feedback. You know, guys, if we want to improve, we want to provide you the best podcast experience for all those ROS developers that are around there. So that's all for today. Yeah, see you next week with a new lesson from the experts. And until then, keep pushing your ROS learning.
podcast, the